All right, let's get right into it. Today, we're going to be breaking down how to protect one of the most valuable things in the world right now, the data that fuels our AI systems. So, let's dive into the blueprint for how it's done.
You really have to think about it like this. An AI is only as good as the data it's trained on. And that data, well, that can be anything. Personal photos, private conversations, sensitive company secrets, even our medical histories. That makes every single AI system out there a massive target, kind of like a digital Fort Knox. So the real challenge isn't just about making AI smarter, it's about making it secure enough to fend off attacks trying to steal or mess with its core data.
And that is exactly where this blueprint comes in. This is going to be our roadmap for this explainer. You can see it breaks down all the essential security controls for an AI system, everything from encryption to data safety rules. We're going to go through this piece by piece, starting with the outer defenses and working our way in. You'll notice it's split into two really critical layers. Let's start with the foundation. So our first layer of defense is all about building these completely unbreakable walls around our data vault. This is what we call the encryption layer. You can think of it as the brute force protection, the fundamental security that makes our data totally unreadable to anyone who doesn't have the key. This first control handles a major weak point, movement. See, data is almost never just sitting in one place. It's always zipping around, from your phone to the cloud, between different servers, or from a user to the AI model itself. Encryption in transit basically puts that data inside a secure container while it's on the move. It's just like that armored truck. Even if somebody manages to hijack it, they still can't get inside to see what's in it. Okay, so what happens once that armored truck gets to its destination? The data gets unloaded and it gets stored somewhere. That is where encryption at rest comes into play. This is what protects data when it's just sitting there, on a server, in a database, somewhere in the cloud. This is the high-tech, impenetrable lock on the main vault door. Even if a thief somehow breaks into the bank, they still can't open the vault. Now this is the final and probably the most advanced piece of the encryption puzzle. Data isn't just moving or sitting still. The AI actually has to use it. And in the old days, that meant you had to decrypt the data to work on it, which left it vulnerable, even if just for a second. Encryption in use completely changes the game. It lets the computer process the data while it stays encrypted. Just imagine a mechanic working on a car engine inside a locked, solid black box. They can fix the engine without ever actually seeing it. That's the idea here. It means the data is protected at every single stage, when it's moving, when it's stored, and even when it's being processed. So we've built our walls. They're strong, they're impenetrable, but what happens on the inside of the vault? Well, that brings us to layer 2, the data safety layer. This part isn't about brute force anymore. It's all about intelligence. Think of these as the smart guards who manage everything happening inside the fortress. Encryption is great, but it's really an all-or-nothing kind of thing. Data safety is much more nuanced. It's a set of smart rules and procedures that decide how data gets handled, even by people who are authorized to be there. It's all about making sure people only see what they're supposed to see, and that the data itself is handled in a way that protects everyone's privacy. First job for our smart guards is anonymization. Let's say our AI needs to learn from thousands of customer files. Does it really need to know that customer number 3452 is named Jane Doe and lives on Main Street? Probably not. Anonymization just strips out all that personal info, cutting the link between the data and the actual person. The AI still gets all the valuable patterns it needs to learn, but Jane's privacy is kept totally safe. Next, our guards need to know exactly what they're protecting, and that's where data classification is so important. It's basically like giving every single file a security clearance. Some data is public, anyone can see it. Other data is confidential, so only certain employees can get to it. And then you have top secret stuff, which is locked down for only a very small number of people. By tagging every piece of data, the system automatically knows who gets to see what. So we've been talking a lot about how to protect the data we have. But what if there was an even more powerful, a more fundamental way to keep data safe? It really boils down to this simple but pretty powerful idea. The most secure data is the data you never collected in the first place. This is the whole philosophy behind our next control. The best security measure isn't a better lock or a smarter guard. It's simply having less treasure in the vault to begin with.
And this principle has a name: data minimization. It means before you collect even one bit of information, you have to ask yourself, do I absolutely 100% need this to make the AI work? And if the answer is no, then you just don't collect it. It's a proactive defense. By shrinking your data footprint, you shrink your risk. It's simple. If you don't have the data, it can't be stolen.
And finally, let's just quickly clear up two techniques that people often get mixed up: redaction and masking. On the one hand, you have data redaction. That's like taking a big black marker to a document. You are permanently removing and deleting the sensitive info. It is gone for good. On the other hand, there's data masking. This doesn't remove the data, it just replaces it with fake but realistic-looking data. So a real name like John Doe might become Adam Smith. This is super useful for things like testing systems because the data looks real, but no one's actual private information is being exposed. So the key difference is just this: one removes, the other replaces.
Okay, so let's just take a step back and look at the whole fortress we've built. We've laid the foundation with our unbreakable walls, and we've put our smart guards on duty inside. So how does this all come together to build an AI that's actually secure? When it comes down to it, this isn't a choice between one or the other. A really strong security plan needs both of these layers working together perfectly. You need those unbreakable walls of encryption to protect the data from outside threats 24/7. And you need the smart guards of data safety managing everything intelligently and responsibly on the inside. Together, they create the complete fortress.
And that brings us to our final thought. We've just walked through the current blueprint for AI security. But as these AI systems get more and more powerful, and as the data they use becomes more and more valuable, you can bet the threats are going to get more sophisticated too. So the question we're left with is this: will the fortress we can build today be strong enough for the challenges of tomorrow? Thanks for tuning in.